This lesson is on properties of exponents, focusing on two specific properties, the zero exponent property and negative exponents. So if you could pause this video and take a few minutes to do your best to complete the exploration. There's 3 tables where you can fill in all those values. Notice it does say to write answers as fractions, no decimals, and then answer the 3 questions below. Once you're done with all of this, then go ahead and hit play to see how you did. All right, let's check and see for table 1. 2 to the 4th power is 16, 2 cubed is 8, 2 squared is 4, 2 to the 1st power is 2, 2 to the 0 power is 1. You could use your calculator to get these, or you can just do 2 times 2 times 2 times 2, and so on. When you get to the negative exponents now, in your calculator, 2 to the negative 1 would give you 0.5, but if you convert that back to a fraction, we should have 1/2. 2 to the negative 2 would be 0.25. Convert it back to a fraction to get 1/4, and 2 to the negative 3 would be 1/8. So check and make sure you found all of those correctly. In table 2, the correct values going down this table should be 81, 27, 9, 3, 1, 1/3, 1/9, 1/27. And in the last table, with all of our bases being a 4, 4 to the 4th power is 256, 4 cubed is 64, 4 squared is 16, 4 to the 1st power is 4, 4 to the 0 power is 1, 4 to the negative 1 is 1/4, 4 to the negative 2 is 1/16, and 4 to the negative 3 is 1/64. So to answer the first question asks, do you notice any patterns as you fill in the table from top to bottom? So if you look at table 1, to get from 16 to 8, and then 8 to 4, and 4 to 2, and so on, we're dividing by 2 each time. 8 divided by 2 is 4. 4 divided by 2 is 2. 2 divided by 2 is 1. 1 divided by 2 is 1/2. Divide that by 2, you get 1/4. Divide that by 2, you get 1/8. Especially when we get into the fractions, remember dividing by 2 is the same as multiplying by 1/2. So I think it's a little easier to think of it that way. So I'm going to make a little note down here that in table 1, we multiply by 1/2 each row. All right, in the next table, when the base is 3, notice that now to get from 81 to 27, you divide by 3. 27 to 9, you divide by 3. 9 divided by 3 is 3. Remember, it's the same as multiplying by 1/3. So 1/3 of 3 is 1. 1/3 of 1 is 1/3. 1/3 of 1/3 is 1/9. Times 1/3 by that, you get 1/27. So in table 2, we are multiplying by 1/3 each time. And similarly in this last table, you should also notice that every single time you could either think of this as dividing by 4 or multiplying by 1/4. So the next question is, what do you notice about base raised to the 0 power? So in each table, I'm going to highlight when we had the number raised to the 0. And following each of those patterns, you can see that in every table, we ended up with a 1. So I'm just going to put a 1 here. So anything to the 0 power is 1, and that's the first property we'll look at today down below in just a few seconds. The last question first, though, is what do you notice about a base raised to a negative power? So first thing I want to point out is that none of our answers are negative. Every time we had a negative exponent, which is these last 3 rows, our answer became a fraction where that value moved to the denominator of the fraction. So once again, none of our numbers are negative answers. We just have fractions where we basically like move that value to the denominator or the bottom of a fraction. So I'll go ahead and write that down. So we'll get to that property on the next page. Going back to the 0 property, it says here to divide 5 to the 8th by 5 to the 8th. So if we use our division property, dividing powers with the same base, where we subtract the exponents, if I do 8 minus 8, that's a 0, and then 5 to the 0 is a 1. Now, since this property we didn't really say yet, Another way we could come up with that is we have 5 times itself 8 times on top, and on the bottom, same thing. 5 to the 8th power is 5 times itself 8 times. So if these cancel, and so on, we're left with 1 over 1, which is 1, because everything cancels. So the rule here is that anytime you have anything to the 0 power, it will equal 1, like we see here and like we saw in the 3 tables above. What you have to be careful about, though, is when you see a 0 exponent, your answer is not automatically 1 every single time. Now here in part A it is, but in part B, only the x is to the 0 power. The 5 is being multiplied by that answer. So since x to the 0 is a 1, then 5 times 1 gives us a final answer of 5. In part C, we have parentheses around the entire fraction to the 0 power, so that is simply just 1. Where in this one, the only thing to the 0 power is the x to the 0, so that becomes a 1. And then I still have a 4y to the 8th over negative 2y to the 5th. And I can just use my division properties to simplify this to negative 2y cubed. So I'm dividing the 4 and negative 2, and I'm subtracting the exponents with the 8 and the 5. All right, moving on to the next property. If I write this out the long way, x to the 4th power is x times x times x times x, so 4 times. And x to the 6th power is multiplying x by itself 6 times. So if I cancel an x on top with an x on the bottom, and another, and another, and another, I'm left with 2, and where are they? On the bottom. So one way of looking at this without dealing with any negative exponents is when you're subtracting, you basically find the difference between those two numbers and then just look right away to see where do you have more of them. And in this case, we have more x's on the bottom, so the leftover x's are on the bottom. Now, if we use our division property, where we can take 4 minus 6, then we get a negative exponent. So then we'd have to say, well, if we have x to the negative 2, we just move it to the bottom and make the exponent positive. So that shows us this first property, a to the negative n equals 1 over a to the positive n. And what we haven't seen any examples of yet is what if you start with a negative exponent in the denominator, like 1 over x to the negative 3. So what's going to happen now is that is going to move to the numerator and become positive. And that would be our answer. So that's what this second rule is telling us, that if we have 1 over a to the negative n, it equals a to the positive n. So in other words, any negative exponent, if it's in the numerator, it moves to the denominator moves to the numerator, and it changes from negative to positive. So that's what that sentence below is saying. Let's take a look at some examples of this. Example 2a, since I have a negative exponent, x to the negative 5, I change it to x to the positive 5 and put it in the denominator, so there's my answer. Now in part B, this starts on the bottom, so it's going to move up to the top with the 3, so I'll end up with 3y to the 6th. Part C, I'm going to rewrite both of these, so the 3 to the negative 2, I'm going to move to the bottom, make it positive. 3 to the negative 5, I'm going to move to the top, make it positive. And now when I have a division problem with powers that have the same base, I can just subtract the exponents. 5 minus 2 is a 3, and 3 cubed is 27. The other way of thinking about it is you have 5 3's on top and 2 3's on the bottom. So if you cancel 2 on top with 2 on the bottom, you're left with 3. Part D. Here, if I just rewrite everything, getting rid of negative exponents, nothing happens with that 2. This x to the negative 2 will move to the bottom, and then the x becomes positive, or the exponent becomes positive. Y to the 3rd will stay on top. And z to the negative 5, that's going to move to the top. and the 5 becomes positive. So that's our final answer on part D. Notice that all 4 bases, the 2, the x, the y, and the z, are all different. So there's nothing to multiply or divide. We simply are just rewriting the problem to get rid of anything that has a negative exponent, and these parts stayed exactly where they were in the numerator. All right, this one's similar, so why don't you go ahead and pause the video and try part E. When you're done, then go ahead and hit play to check your answer. So the answer here would be a negative 8. A to the negative 3 moves to the bottom, becomes a cubed. B to the negative 4 on the bottom moves to the top, becomes b to the positive 4. C to the 5th stays on the bottom. There's my final answer. Once again, the negative 8 and the c to the 5th stay where they are. And then the a moved to the bottom, b moved to the top. Those exponents changed to from negative to positive. You might wonder why the 8 didn't move, because there is a negative there, but it's not an exponent. It's just a negative 8. So negative 8 just stays where it is. It's when the exponent is negative that it moves to the other side of the fraction. All right, there's a couple options for how we can do part F. One thing I like to sometimes do is just start out by getting rid of all the negative exponents, which all 4 of them are negative here. So x to the negative 4 will move to the bottom, become x to the 4th. Same with x to the negative 6, moves to the bottom, becomes positive 6. X to the negative 5, I can move to the top, x to the 5th. And same with x to the negative 3, that'll move to the top. Now I can use my multiplication property. If I multiply powers with the same base, I add the exponents. So on top I have x to the 8. Bottom is x to the 10th. And from here you have your 2 options of either subtracting. 8 minus 10 is negative 2. And then move it to the bottom, make it positive. Or you can go right from that step, x to the 8th over x to the 10th, and just think of it as 8 of them on top would cancel with 8 of them on bottom, and I'd have 2 extra on the bottom. Before we move on to the next one, I did mention how there's different ways you could have done this. I chose to get rid of all the negative exponents right away. But you also could have used your multiplication property right away and multiplied the powers in the numerator and multiply the powers in the denominator. When I add those exponents, I would get x to the negative 10 and x to the negative 8. And then from here you can subtract the exponents, or you could get rid of the negatives and then subtract, and now we're at the same step we were down there in blue. So with some of these problems, there's many different ways of doing it, but as long as you do it correctly, you should get the same answer. All right, part G, maybe on G or H or both. Go ahead and hit pause, try it yourself, and then hit play to check it. So let's start by checking the answer to G. In G, we have a negative 4. And let's start by getting rid of the negative exponents. So a to the negative 5 will move to the bottom, make it positive. The b is going to stay where it is. A to the negative 3, I'll move to the top, make it positive. B to the negative 7, I move to the top, make it positive. Now I'm not done because I have 2 bases with a and 2 bases with b, so I have to combine those. The a's will get divided, the b's will get multiplied, so with the exponents for b I add and for the a's I subtract. So I'll have a negative 4, b to the 8 when I add 1 plus 7. And then here I can either subtract and get a negative 2 and then move it to the bottom, or right away just put a squared on the bottom because I can see it's bottom heavy and there's more a's on the bottom than the top. So then I don't have a negative exponent, I just use a positive 2. If, once again, just to clarify there, if I did get the negative 2 as the exponent, that would be on top. Then I'd have to move it to the bottom. Okay? All right, last one. Let's check H. 10 divided by 5 is 2. And then if these 3 x's move on top, I have x to 8 on top. If these 2 y's move to the bottom, I have y to the 6 on the bottom. There's my final answer for part H. All right, one last thing to finish up this lesson is if you have a fraction to a negative. Let's look at part A to see kind of one option you have on doing these problems. If we just start with our quotient property where we have a quotient to a power, we have to take the numerator to that power and the denominator to that power. So if I have x to the negative 2 over y to the negative 2, I can move x to the negative 2 on bottom and make it positive. Y to the negative 2, move it to the top and make it positive. And there's my answer. So another way we could have done this is, since we know with a negative exponent that everything is going to be raised to the negative and anything on top moves to bottom and bottom moves to top, you can right away take your fraction and flip it. It's also called the reciprocal, and make the exponent positive. And from here, then y squared over x squared would give me the same answer. So when you have a fraction to a negative, you can take the reciprocal of that fraction, change the negative exponent to a positive, and then simplify. Let's try this with the last two examples. If I take this fraction and flip it, y to the fourth would be on top, 2x would be on the bottom. When I raise all that to the third power, now I have y to the fourth to the third, so y to the 12th. On the bottom, 2 to the third is 8, and then x to the third, and there's my answer. So is this the only way to do it? No, but this is one option to do the reciprocal and make that exponent positive. So this is just when we're dealing with fractions. Your other option would be to take all your bases or your powers, like 4 to the negative 2, x to the negative 3 to the negative 2, and y to the 5 to the negative 2. Okay, that's your other option. But what I'm going to do here is the same thing I did before. Change that negative exponent to a positive and take the reciprocal. Y to the fifth over 4x to the negative 3. Now notice this negative didn't go away. All right, so now you kind of have two options. You could either rewrite this problem with getting rid of that negative exponent. So I can move x to the third to the top with the y to the fifth, 4 on the bottom, and now square everything. So this would be x to the 6th, y to the 10th over 16. Your other option could have been from here to take everything to the second power. So y to the 5th to the 2nd is y to the 10 over 4 squared, which is 16. X to the negative 3 squared is x to the negative 6. And then finally, we can't leave a negative exponent in our final answer. We'd move it to the top, make it positive, and that would give us the same answer we got over here. All right, that concludes our lesson on properties of exponents when we're dealing with exponents of 0 or exponents that are negative.